Hello everyone. In this video I wanted to give you some insight into the activity that you were asked to complete. Again, the guiding question was what factors affect the force of friction that a object will experience. After brainstorming some of these ideas about what factors affect the force of friction an object experiences, you had to select one of them and design an experiment to test whether or not that factor actually affects the force of friction. This video isn't to give you insight into that, but actually to hopefully take some of what you're measuring during the lab and create hopefully a better analysis for you. Quite often students will want to measure the distance an object travels, or the speed at which it travels, or the time that it takes it to stop. And although these can be useful pieces of data to collect, that doesn't necessarily guarantee that the force of friction is greater. In other words, I can't necessarily say because one object took 10 seconds to stop and another object took 20 seconds to stop, that the one that took 20 seconds there was less friction, because I didn't actually measure the friction. So how can I actually take that piece of information, that 20 seconds, and actually turn it into something that is useful, so therefore I can determine what the force of friction is. A lot of this all stems from the correlation doesn't mean causation. And I found this little chart here about the sales of sour cream and correlating with deaths from motor bike accidents. And there's a pretty strong correlation between them. It's like 92%, so that seems as though clearly if people consume more sour cream, then more motorcyclists get killed. And this is a little frightening considering I am a motorcyclist. So I guess I'll make a small plea for all of you watching this video to stop consuming sour cream. There's sort of two main themes, if you will, dealing with Newton's laws and this particular activity. What if the net force is zero? Well, then the object must be moving at a constant velocity. This simplifies things quite a bit. Assuming that this object is sort of being dragged across a floor or across a table, the gravitational force and the normal force have to be equal because the object's not accelerating upward or downward. And if it's moving at a constant velocity, the applied force and the frictional force have to be the same. So if you're measuring the applied force with a spring scale or other force measuring device, then it becomes pretty obvious that the force of friction has to be the same value. What's also kind of neat is if in fact you actually get if you place the object on a ramp and get it to slide down the ramp at a constant velocity. I know you might be sitting there saying, well, wait a minute, how is that possible? How is the net force zero? Well, again, if it's moving at a constant velocity down the ramp, then the net force must be zero. All of the ups and downs and lefts and rights have to sum up to zero. And in that particular case, the force of friction would be acting up the ramp. And it actually would be the weight, a portion of the weight, I should say. See how there's a right triangle here? This side over here would sort of be mg sine of theta, which in this particular case happens to be 30. So if you knew the mass of the object, and you also knew that the angle that would cause it to slide down at a constant rate, you could figure out this component of the weight of the object, and if in fact it was moving at a constant velocity, that component of the weight would equal the frictional force. But once again, that is under a net force being equal to zero situation. The other situation is when the net force isn't zero. So the object must be either speeding up or slowing down. In the case of speeding up, that means that the push has to be greater than the force of friction. And again, I'm kind of assuming that the weight and the normal force are the same. I'm not accelerating up or down, I'm just having acceleration in one direction. So in this case, if you could determine what the acceleration of the object is, by determining the distance that it travels over a certain time and making sure that you use the kinematic equations that describe accelerated motion, not constant motion. That's not a difficult calculation to do. And if you knew the mass of the object, which you could mass it relatively easily, then you could sit there and figure out what the net force on the object is. If you knew what this applied force, or this push was, the push minus the frictional force would give you that net force. So that all comes back to just the net force causes the mass to accelerate. You would mass the object, you would calculate out the acceleration, and then using the, if you have to know what this push was, if you will, that would sit there and allow you to solve for the force of friction in that case. The other case is if the object is slowing down. I think the easiest way to do this one is to just let friction slow the object down. Again, if you know what the mass of this block happens to be, again, I'm assuming it's kind of sliding along the ground. If you know what the mass is, and you could determine the acceleration of the object, again, by measuring a distance and a time, to determine the acceleration of the object, and the only force that's acting on the object is the force of friction, then the frictional force becomes the net force. So if you knew the mass of the object, and you knew what its acceleration was, the force that would be causing that object to slow down would be the force of friction, and thus you would know that your net force is just the frictional force in this case. I hope you found this video helpful in your analysis and hopefully not having to throw all of your data away. And another misleading statistic, over 2 million Americans exposed to drinking water will die this year. Thanks for watching.